Hey guys, this video is all about composition of functions. Now, it's a big word, but really all it's saying is I'm going to take two functions and I'm going to plug them into each other. So it's really just a big way of saying substitution. So a composition of functions is written as the f with the o, okay? Written almost like fog, some people write it. Or it's f brackets g of x. It means I'm going to take whatever g of x is and I'm going to put it into f. So in these cases, okay, I'm going to take f of g of x. So it's f of g of x, okay? So I have all these points, okay? So this is to illustrate how to do it. So I'm going to go to g of x, okay? So I'm going to say, okay, if I plug in 1, I get 3 back, okay? Right, 1, 3, x, y. Now I'm going to take that 3 and I'm going to go, okay, where is 3 in my f function? Well, 3 is right here, okay? So if I plug in 3 to my f, I get 3 back. So my f of g of 1 is 3. And I go through the list, okay? Now I do my f of g of 3. So I start with 3 in my g. It goes to 4. 4 in my g function, boom, goes to 1. So it's 1. Okay? F of g of 2. 2 goes to 2. Well, then I find 2 over here in my list here. Boom. 2 goes to 4. Okay? And my final one, f of g of 4. 4 goes to 1. 1 in my list over here goes to 2. Now, I know what you're saying. Okay, what if this number is not in this list over here for my x's? Okay, then it doesn't work, and you just write does not work. Okay, are you all set? All done? You're on that one. Okay, that's fine if you don't finish that one. I'm gonna give people like 10 minutes, 15 minutes to work on.
Oh no, I can finish it. It's just I can finish it. I was just turning my phone.
Oh, okay. I thought you were catching the bus. Okay, so what I can do is I can actually reverse that too, and you can see that I can get different numbers. So I would do g of f of 1. Well, f goes to 1. 1 goes to 2, and then I find 2 in this list over here, and that goes to 2. Okay? So you see how that changes, that answer. G of f of 3. Well, 3 goes to 3. 3 goes to 4. Okay? So my y's in this case become my x's over here. G of f of 2. That 2x is my x, goes to 4. That's my y. That 4 goes to my x over here, and that equals 1. Okay? And my g of f of 4. So 4 is my x, it goes to 1 as my y. 1 as my x in my g function goes to 3. So all I'm doing is taking my x's in here. I find what y value it has. I take my y value and I plug it in as my x over here and I figure out what that y is. It's a little bit easier when we look at functions. So what we want to do is we want to compose, okay, g of h of x. Okay. Now, again, I don't have any numbers. I just have two functions. So what I do is I take that and I substitute it in to the other. So in this case, I'm going to take my h of x, okay, my h of x, and I'm going to plug it in for every x in my g function. So I'm going to take my g, and I'm going to plug in x squared minus 1. Well, my g function is 3x minus 4. So I start writing that. 3, every time I see x, I'm going to replace it, x squared minus 1 minus 4. Now I distribute the 3 in. And now I combine like terms. So that is my g of h of x. Now I reverse it. So I do my h of the g function. Well, the g function is 3x minus 4. So I write it out. Every time I see an x, now, you notice that I put it in parentheses because it's x squared. So I have to take this 3x minus 4 and square it. So I'm going to take this 3x minus 4 and I'm going to multiply it by 3x minus 4. Now I have two what we call binomials, but I have to do the distributive property where I multiply. You might also remember this as foiling. So I would do the 3x times everything in here. So 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. So I've distributed that 3x in. And now I take this negative 4 and I distribute that in. Negative 4 times 3x is negative 12x. Negative 4 times negative 4 is positive 16. And I haven't done anything to this one, minus 1. Now I combine my like terms. Now I can't combine anything else. That is my h of g of x. What you have to remember is when you're squaring something, oftentimes with polynomials, okay, you have to distribute in and you're going to add exponents when you multiply. So that is how you're going to do these next practice problems. So again, this is like example 1. This is like example 2. Okay, please check your answers online.